Good evening, dear students. Welcome to our learning channel, through which you can able to update your concepts to tackle problems in mathematics without any difficulty. Do watch previous videos completely so that you get the consistent update on concepts. So this is the continuation of the previous video. Under matrices, topic 1 we are dealing fundamentals. First topic is fundamentals. It is part 6. Part 6. Types of matrices we are going to continue, and in this video I am going to conclude the types. Means this types of matrices will be covered in this video. In next video what I am going to post, there the topic name will be topic 2. Here fundamentals already have given on topic 1. This will change. Operations on matrices. Operations on matrices. So based on topics, the titles will be different. So be careful. Under topic 1, we are discussing the last video of types of matrices. So have a glance of these things, and we are going to discuss one by one. So far we have covered what is the form of the matrix, how to name it. But here, if any matrix, any square matrix satisfies a special property or a rule is called mathematical property, then we are going to name that matrix in different way. So these are the types based on the property based. Those property they must satisfy, the matrix must satisfy. Then that name will assign to it. So before that, I am going to give you small information about one small operation called transpose of a matrix, because that is been used here to define the property. Let us continue. So first of all, you should know what is the meaning of transpose of a matrix. Any matrix, it may be square or rectangle. Transpose of a matrix. How you are going to define this? If every row or column, if every row, any one option, either you choose rows or column, not both, you have to choose any one. If every row or column of a given matrix A, by default, this A may be rectangular or square. In brackets I'm writing either square or rectangular matrix. No restriction. If every row or column of a given matrix capital A, either square or rectangular matrix, is transformed, we can use one more letter also, interchanged, or we can write written as, if you select row, we should get column. Here we get row. Be careful. If you pick up every row and you are going to write down each row as column, or you take every column, write down in row fashion, the new matrix, whatever you are going to get, is called transpose of that matrix. Transpose of that matrix. This plays a vital role in defining some properties. Other properties. Transpose of a matrix. For example, hope it is clear to you. If every row or column of a given matrix A, no restriction here, is transformed or interchanged or written as column or row, then the new matrix so formed is called The way is called the transpose of the given matrix. So this is the information about the transpose. It is a property of a matrix. What is to be done? Now I am going to quote one example so that it is very clear to you. I hope that definition of the transpose of a matrix is very clear to you. So this example, let us take one example. I am taking a matrix A whose rows are 3, columns are 2, a rectangle matrix. Let us take 3 rows are there. I write 3 different numbers. We will write 2 times 2 columns. It is 3 by 2 because 3 rows are there, R1, R2, R3, C1, C2. Now A transpose, we write power T to do A transpose. If you take transpose, rows become columns, columns become rows. So it becomes 2 by 3. It is called transpose. Transpose of A. Transpose of A. So how you write? Your rows are 2, columns are 3. Just flip that number. Now what I gave you in the definition, if you pick up any row, write that row as column, or if you pick up any column, write that column as row. So here you see I am taking rows. First row R1, row R1, it becomes column 7 minus 4. Next row 0 1, it becomes column here. Third row 4 6, it becomes column here. Now rows are 2, columns are 3. This is called transpose of this. If it is 3 by 3 matrix, order will be same, but the way you write is important. If I take A3, a 3 by 3 matrix, 2 1 4 0 1 6 negative 1 4 3, I took a square matrix of size 3 by 3, right? Its transpose A power T. How you write? Here this is R1, R2, R3, C1, C2, C3. Here I picked up each row and wrote column wise. Here what I will do, other way around. Here I will take each column, I write row wise. So first column 2 1 0 minus 2 0 minus 1. Write in row fashion. 2 0 negative 1. Next column 2 1 1 4. Column 3 4 6 3. Order will be same, but you see both are different. Both are different. It is A transpose, it is given matrix A. Here I took square matrix, here I took rectangle matrix. Now we are going to conclude remaining types of matrices. As I told you, they are property based. If any square matrix satisfies a special property or a mathematical rule, then we are going to name that square matrix in different way. So these are the things. It is 10th one in the list, orthogonal. Orthogonal matrix. In geometrical sense, the meaning of orthogonal is perpendicular. Perpendicular. But don't call it as perpendicular matrix. Just I gave the meaning of this. Because of this meaning, it carries P letter as the first letter. We take that letter to denote orthogonal matrix. So the property, what property to show? When you say the square matrix, here I took P, capital P. I am not writing the size here, it is understood, right? The square matrix P is said to be, is called, or you can write, is called an orthogonal matrix. Orthogonal. Orthogonal matrix if it satisfies the property, as I said, property or rule we can say, or we can say condition. Condition. If you take the product P into P transpose, you get I. I stands for identity matrix. This already you know, just like a word, transpose. Transpose of P. P into P transpose if it gives I. When we discuss in next topic regarding operations on matrices, they will explain how to multiply two matrices. It is the product of two matrices, the product. This is nothing but product. Product is the word you are going to use when you multiply. Product of P and P transpose. When you are going to use multiplication operation, we use the word product. Product of P and its transpose. If this property holds, and P is called what? Orthogonal matrix. Next, so this is the other one based on property symmetric matrix. Symmetric. In general, symmetric means exactly mirror image. If you stand before a mirror, we can see our face exactly in lateral inversion mode. Left becomes right, right becomes left. So symmetry, exactly same on either side when we look. In that sense, symmetric matrix is the same thing. The square matrix capital A is called a symmetric matrix if it satisfies the property or rule or condition, this one. If you take a transpose of that square matrix, we get back A again. A transpose is equal to A. Here I wrote A port is nothing but transpose of A. I am going to give you an example how to inspect the given square matrix is symmetric matrix. Symmetric matrix. Generally, there are two types are there: real symmetric matrix and complex symmetric matrix. When the matrix elements are all real numbers, we use the word real symmetric matrix. Even if one complex number is there among the elements, it comes under complex symmetric matrix. So separately, a video will be there on complex matrices. Don't worry. There I am going to cover different terminology of types. So I am going to give one example for this, how to inspect directly for a symmetric matrix. Just have a look of the definition. It is a property. This is a property. If any square matrix satisfies property, then that matrix, the square matrix, is called symmetric matrix. Symmetric matrix. Let us see the example. I'll take capital A is equal to. So to give the example for the symmetric matrix, you choose any numbers for diagonal. I took three elements here, 8 to 9 along the diagonal. It is your choice. And take care that suppose if I take any random elements above the diagonal, minus 3, 4, 2. Be careful. You take any random elements of your choice along the diagonal and also above. And also above part. Just you copy the elements which are above exactly below that diagonal. It is your diagonal, main diagonal. You choose any random elements, the diagonal elements, and also above. Just you copy the same elements below the diagonal. That will be a symmetric matrix. Minus 3, here 2, here 4. So this is your symmetric matrix. For example, I have taken this one. If you take A power T or A transpose, you are writing each row as column. What do you get? 8, -3, 2. Next, second row, -3, 2, 4. Third row, 2, 4, 9. You just see it is exactly A matrix. Exactly A. A transpose equal to A. This matrix is called symmetric. Symmetric matrix. This diagonal act like mirror. Mirror above and below, same elements will be there. Without finding transpose, we can inspect and give the answer. Symmetric matrix. Let us continue. 12th one, skew symmetric matrix. Skew means twist. Just a twist or flip. So here I gave the definition how to define. Here also same, the property of square matrix. A square matrix capital A is called a skew symmetric matrix if it satisfies the property or rule or condition A transpose is equal to negative A. Actually it is called negative A. Negative A means you get the matrix by multiplying every element by -1. If you multiply the every element of a given matrix with the -1, just we have to take additive inverses of each element. That is called negative A. It is also called as, I write the special name for this to identify this. Already you know, this is transpose of A. We discussed transpose of A. This is called additive inverse. Additive inverse. This word you must know. Inverse of A. Be careful. Additive inverse of A. We will discuss one more in separate video. Multiplicative inverse of A. Here it is minus A. How it is obtained? By multiplying every element of given matrix A with a -1. Actually, it is equal to, it is not negative A, -1 times A. That is equal to negative A, we write. What is the meaning? Multiplying every element of matrix A with -1, we are going to get negative A. That is what? Additive inverse of A. If this property is satisfied, the square matrix A is called skew-symmetric matrix. Skew-symmetric matrix. Now I am going to quote one example how to inspect just like symmetric matrix to give an example for skew-symmetric matrix. The same video, we are going to conclude the remaining two are there types that will be covered. A. Here, there I told for symmetric matrix, you can take any random elements for diagonal and above. Here, you choose zeros along the diagonal. Zeros along the diagonal compulsorily. Random numbers here. 7, 5, -4. I took random elements above the diagonal or below diagonal. Any one choice. Diagonal elements must be 0. You can choose random elements above or below. And to get the elements of below the diagonal, just you have to take the additive inverse of 7. It is -7. For 5, it is -5 or -5. For -4, it is +4. Just quite opposite sign. Right? Thing is that 7 - 7, 0. 5 - 5, 0. 4 - 4, 0, like that. Now you can check the property. You take A transpose for this. You can choose either column wise or row wise. Correct? If you want to write each column as row, first column 0, -7, -5. Next column 7, 0, 4. I am writing each column as row. Third column 5, -4, 0. Right? This is equal to, now what I will do, I will multiply with -1, right? So 0 has no sign, it remains as it is. Minus came out, we get 7 here. Minus came out, we get 5 here. Minus outside, it must be -7 to get plus 0 as it is. Here -4, why? Because -4 into -1, we get +4. Here -5, why? Because -5 into -1, we get +5. Here we get 4, because 4 into -1, it is -4. Here 0, you just check, it is -a. Minus, it is nothing but a matrix. A matrix. That is why it is called, area is called skew-symmetric matrix. So let us continue. 13th one. Type 13. I wrote property here. What is the type of the matrix we are going to name? Here I took square matrix only. You see, all types are named using square matrices. A into A is equal to A. If you multiply the matrix 2 times, if the product is again A, then the matrix, square matrix, is called idempotent matrix. Idempotent matrix. In some textbooks, they will write like this. This property you can show like this: A square equal to A. Using algebra, A power 1 into A power 1, A power 2 we get. So A square equal to A. If A square equal to A, where A is square matrix, then that matrix A is called idempotent matrix. This is a property. If any square matrix A or whatever you take satisfies this rule, then that matrix is called idempotent matrix. Next one, 14th one. A into A. Here also same thing, but instead of A, we get identity matrix. Identity matrix. In this case, the square matrix, whatever you multiply 2 times, is called involutory matrix. Other way around, we can show this property as, you take A square by using algebra, A square equal to I. A square equal to I. A square equal to I. So A square equal to A, idempotent matrix. A square, if it is I, if it gives ID matrix, then it is called involutory matrix. And one more is the 15th one, the last one. We are going to conclude that types of matrices in under the topic called fundamentals, topic 1. So that is very simple to understand in the same way what I wrote here. 15. The property highlight or condition, whatever you say, type. So what is the property? Here we are going to write down. So here A power small n. If you write power n, we have to multiply the square matrix n times. If power is 3, we have to multiply A 3 times. If n is 4, multiply the square matrix 4 times. So the meaning. In previous 2 types, I have taken A square, multiplying A 2 times. A square equal to A, idempotent matrix. A square equal to I, involutory matrix. So here, some n I took, A power n is equal to null matrix. It is zero matrix or null matrix, you know, discussed earlier. O. It is O. It is also called zero matrix. Zero matrix. Of course, here A is a square matrix. A is a square matrix. Here n I wrote there, power small n. This is called index. Index. Generally, n can take 2, 3, 4 like that. I write in bracket. N can be 2, 3, 4, 5, depends. The thing is that what is the value of n you should take? First you take 2. You are not going to get 0. Null matrix. You take 3, multiplying A 3 times. There you are not going to get null matrix. Multiply 4. You got null matrix. So 4 is the index. That means index means the least positive whole number. So what is the index means? The least positive whole number to be taken here. Suppose if I take 2 and multiplying A 2 times, you are not going to get a null matrix. Some other matrix you got. So 2 is not the index. Now you take 3 there. What is the meaning? Multiplying A 3 times. Then also you are not able to get null matrix. So 3 cannot be the index. You take 4. Multiplying A 4 times. Then also you encountered different matrix, which is not null matrix. So 4 is not the index. Then you took 5. By multiplying A 5 times, you received or you reached null matrix. You stop. 5 will be the index. Even if you take 6 there, we get again null matrix. 7 null matrix we get. 8 null matrix. So I'll give the meaning of that. What is the index of this matrix A? I didn't write the name here. Later I'll write. So if I multiply A 2 times, suppose you are not going to get the null matrix. Then what you do? We multiply one more time. That's A power 3. Here also we are not going to get null matrix. Suppose we multiplied 4 times. You arrived at null matrix. Now, if you continue multiplying, if you take A power 5, means multiplying A 5 times, then also you get same. If you multiply 6 times, then also you get null matrix. How far you go, same thing, same 0 matrix you are going to get. So, you see, compare. First time when you are getting null matrix, it is here. Here you are going to get first null matrix. You compare the numbers here 4, 5, 6. It's keep on increasing. Output is only null matrix. Out of these numbers, least one is 4. The first one is 4. Therefore, the index n equal to 4 for this matrix. This example. What is the name of that matrix satisfying this property? A power n equal to null matrix. What is n? N is the index called the least positive whole number. When you reach the first time null matrix by multiplying a number of times. Here I give the example. You do not know when we are going to get first and 0. Suppose accidentally you got here. If keep on multiplying the matrix A again and again, the output will be only null matrix only. First null matrix when you reached, when you multiplied A 4 times, n is 4 there. N is called the index. So what is the name of that matrix? Satisfying property. It is called Nilpotent Matrix. Nilpotent. Because output is nil. Null matrix. Nilpotent matrix. Matrix square matrix is a nilpotent matrix. If the output is null matrix for the least positive integer or whole number, then satisfying this property by any square matrix, the first time when you reach null matrix with some index n, then the matrix is called nilpotent. Nilpotent matrix. So with this, we covered all the 15 types of matrices under types of matrices, right? So be careful, each definition, how to represent, how to remember. There might be confusion in remembering, so be careful about the logic. And the concept points you should remember. What is the meaning of index there? So do subscribe our channel, share it to your friends because learning never ends. It is an infinite platform. So the more you learn, the better you become. Thank you one and all. God bless you.